second goal for this third day in Chapter 5 is for us to be able to integrate problems that require long division. Long division, oh my gosh, that goes all the way back to algebra. Are you kidding me? Let me show you why. So we already did this problem. I'm going to zoom this in so I got a little bit more space to write. We already took care of this. So this number 5, obviously, I've got to do a little division line here so that we don't mix it up because somebody wrote too big on problem number 4. When we go and look at this one, this problem number 5, I see multiple terms on the top. So I could make 3 integrals out of this. What I'm going to tell you when you see these multiple terms on the top is consider doing long division. Long division, what is that going to look like? Well, I would actually take x squared minus 3, and I would divide that x squared minus 3 into x to the 4th, don't have any x cubes, minus 3x squared plus x, and I don't have a constant term. The reason I'm going to do this is I think I can make myself an integral that would be a little bit easier to deal with. So let's say that we carry out the long division. If we carry out the long division, let's see. We'll have to multiply x squared by to turn into an x to the 4th. I'll have to multiply by an x squared. So put it in the x squared column. If I do that, this is an x to the 4th. Minus 3x squared. Don't forget to subtract. If I do that, both those terms drop out, and I bring down my x. Well, x squared minus 3 can't be turned into an x without using some negative exponents, so it looks like this x is going to be our remainder, plus x over a potential x squared minus 3. So this thing up here in the numerator is how I'm going to rewrite this problem. So this original problem is the same as trying to integrate x squared dx plus x over x squared minus 3 dx. So what we just did is we just turned that original problem into 2 separate integrals. And I will tell you, I really like this first one. That first one looks pretty nice to me. So here we turn this thing into, there's my x squared, and there's my x over x squared minus 3 that came from my long division. So now, can we integrate this thing? Well, that's going to be the neat trick. So if we go to integrate this thing, well, I can certainly do that first one. The second one's the one that's going to probably take me a little bit of time. So let's say that u looks like multiple terms on the bottom. Can't do really anything about the number of terms I have, but I see a quantity in the denominator. U is going to be x squared minus 3. Du is going to be 2x dx. When we rewrite the integral, the x dx is going to be the same as 1/2 of a du. So what I really have with the second integral is the integral of 1 over my u with a du and a 1/2 out in front of it. So trying to solve that thing, let's see. So how about 1/2 natural log absolute value, and then I'm going to have I'll have to add a c on in a couple seconds, which I'll do. My u is an x squared minus 3, and then while I'm also at it, this thing is a nice easy one. 1/3 x cubed. And don't forget to add your c. So what's going to happen with problems? With problems like that number 5. Sometimes you're going to have those multiple terms. Sometimes it's going to look very, very complex. And even if it's not that complex, long division, like on the left side of the screen you're looking at right now, can make these integrals a little bit more palatable, a little bit easier to deal with. I guess that's our long division.